Okay, now we're going to talk about fractions, ratios, and rates, and the difference between them. And I'm assuming that this is review. I'm assuming this is something that you've seen before. If it's not, well, just go with it. It's not that complicated, and just having an overview of it will help you later on in the course. Okay, so a fraction always describes parts of a whole. So for example, this, I've got a whole is cut into 8 pieces, and I have 5 of them colored in. And your copy is gray and black and white, so I want you to color that in some color, okay? Um, Over here with the red circles, I have 2 circles. Each of them is cut into 6 pieces. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 of the 6 pieces of the 1/6 size piece. And that is equivalent to 1, so there's the 1, the whole thing, and 5 out of 6 of the other whole circle, okay? Fractions are always written in lowest terms, all right? We always leave our answer in lowest terms. Okay. And then, although a ratio can look just like a fraction, a ratio is used to compare things. Okay, a fraction is describing something and a ratio is comparing two things. So, oh, I need to change my scale so you can see the drawings that I put together down at the bottom of the page. Okay, so we're looking at these balls at the bottom of the page. So if I'm going to compare, I can do part to whole. So I can compare the number of soccer balls to the total number of balls. And there are 5 soccer balls and there are 10 balls in total. And we also leave our ratios in lowest terms. So we're going to reduce that to 1/2. So that looks just like a fraction. We can also, and when we say this, we say it's got a ratio of 1 to 2. All right. And we could write that as 1 and a colon and a 2, and we still say it's a ratio of 1 to 2. Or we can actually write it out with words and say 1 and the word 2 and then the number 2, just to keep you confused, okay? So we can say 1 to 2, all right? We can also compare part to part. So we could compare the number of soccer balls to the number of softballs. So there are 5 soccer balls and there are 3 softballs. So we could write that as 5 to 3 or 5 and the word 2 and the number 3, 5 to 3. All right. We could do part to part to part and so on, because we could compare soccer balls to softballs to basketballs. When we do this kind of comparison, we usually use the colon because the fraction doesn't make sense if you've got more than 2 numbers. So we could do this soccer balls. I've got 5 soccer balls, I've got 3 softballs, and I've got 2 basketballs. Okay? And I can do part to part to part to whole. So that would be, I've got 5 soccer balls, I've got 3 softballs, 2 basketballs, to a total of 10 balls. Notice that the number that I wrote the orders in, the order that I wrote the numbers in, always matched the order that the words were in the description. So the order of the numbers must match the order of the words, okay? It absolutely has to, or else it's just a string of numbers that don't mean anything. Ratios are reported in lowest terms using only whole numbers. Okay, so not decimals. And ratios are never converted to mixed numbers, because it wouldn't make sense. If I were comparing soccer balls to basketballs, I could say that the ratio's 5:3, but I'm not going to say that it's 1 2/3, because does that make sense? No, that doesn't make sense. I can't have a ratio of 1 2/3. 1 2/3 is a single number, whereas if I have a ratio of 5:3, that makes sense. I've got 5 of one and 3 of the other. Okay, so we never convert ratios to mixed numbers. Okay? Okay, let's continue. Now we're going to talk about rates. A rate compares quantities with different units. So, for example, I could read 2 books in 3 weeks, and I could write that as 2 books over 3 weeks. But we usually write it as 2 books and then a slanted line, 3 weeks, where the slanted line is read as per. 2 books per 3 weeks. I have traveling 156 kilometers in 2.5 hours. I could do that as 156 kilometers per 2.5 hours. Or I could write this as 312 kilometers in 5 hours. Okay, then I've gotten rid of my decimal. Notice that I have to have units because the units are different. Okay, so if the units are different, I need to tell you what the units are. All right, one more thing, 2 more things, I guess. The next one we're going to talk about is a unit rate. Okay, unit means 1. Okay, so a unit rate is a rate for one thing. They're often used to compare information, especially costs. And when we have costs, we always do cost over quantity. Okay, so make sure you made a note of that. It's cost per quantity. So for example, if I'm at the grocery store and I'm looking at apples and I'm buying them loose or bulk, the price on whatever day I checked for whatever kind of apple I was looking at this day was $4.34 per kilogram. I'm going to compare this price for loose apples to the price for bagged apples, which on this day was $4.97 for a bag holding 1.4 kilograms. And I need to make a proportion, which I'm hoping you've at least seen before, but if not, I'll explain it here. And what I want to know is, what is the cost for 1 kilogram of apples if I buy it by the bag? And the way I solve this is I'm going to cross multiply and divide. You won't have to do this. Yes, you will in the practice. Okay, so cost equals, and I'm going to multiply these 2 numbers that are diagonal across the equal sign. So my cost is going to be 1 times 4.97, and I'm going to divide it by the other number I have, which is 1.4. We say multiply the pair and divide by the spare. So when I put that in my calculator, I get a price of $3.55 per kilogram. And now I can compare those 2 numbers, and I see that this is the cheaper one. It's cheaper to buy it by the bag than buy in bulk. Okay? Sometimes when we have unit rates, we actually have, so sometimes unit rates for foods are calculated with 100 in the denominator instead of 1, which is why I've got unit rates in quotes. Why would we do that? Well, let me show you an example. Heinz ketchup is sold in 2 sizes of squeeze bottles. Which is the better deal? Well, if I buy the large bottle, which is $3.97 per 750 milliliters, so that's cost over quantity, $3.97 over 750 milliliters. If I just divide that, right? I divide the numerator by the denominator. That's how I change a fraction into a decimal. I get a price of 0.005293 per milliliter. And if I do the small bottle and I do $3.47 divided by 375 milliliters, and again, I'm just going to divide 3.47 divided by 375, I get a unit price of 0.009253 per milliliter. So if I look at these two numbers, they both round to 1 cent or $0.01 per milliliter. They both round to the same number of pennies per milliliter. But if I look at the price per 100 milliliters, so I'm going to do this one as $3.97 per 750 milliliters, and I change that to a price per 100 milliliters, the cost per 100 milliliters. I get my cost here is 0.5293 per 100 milliliters. So that's like 53 cents per milliliter. And on this side, I have 347 per 375 milliliters. Figure out what that is per 100 milliliters. I'm going to label that with an S for the small size. So what I get is that this is going to be 0.9253 or 93 cents per 100 or per 100 milliliters. Oops, I made a mistake back here. Per 100 milliliters. So now I can see, because I compared it per 100 milliliters, this one is almost twice as much. Okay, and yes, I could have seen that looking up at these decimal numbers, but if you look at it in the store, they often put the prices in price per 100 milliliters for things like ketchup and salsa and olives and anything that you don't really, there's nothing we eat a milliliter at a time. Okay, so that's it for these toolkits, and I'll see you on the next video. Bye.